This is the sodium bicarbonate, sodium carbonate mixture problem from the last test. The key to solving this problem is knowing the equation for the decomposition of the baking soda. So we know that sodium hydrogen carbonate is going to decompose into sodium carbonate, water, and carbon dioxide. And both the water and the carbon dioxide are going to be gases. They're going to escape, and that's why the sample is going to lose mass. We need to balance the equation. We're going to have a 2 in front of the sodium hydrogen carbonate. Everything else balances. And so now we need to figure out the theoretical stoichiometry of this. And so let's just assume, for the sake of simple numbers, that we have 2 moles of sodium hydrogen carbonate. Well, that means we're going to make 1 mole of sodium carbonate. We're going to make 1 mole of water and 1 mole of carbon dioxide. So those numbers are nice, but mass is going to be better here because the data from the problem is all in terms of grams. So if we do 2 times the molar mass, 84.01, so we get 168.02 grams. We're not so concerned about the sodium carbonate right now. So let's just focus in on the water, 18.02 grams, and the carbon dioxide, 44.01 grams. And those numbers are just the molar masses of water and carbon dioxide. So adding those two together, since that would be sort of the mass that was lost, the total mass lost here is 62.03 grams. Well, sometimes percentages are helpful. So let's see, 62.03 grams divided by 168.02 times 100. And we're going to get 36.9%. So when baking soda decomposes, 36.9% of the mass is lost. Well, now let's come over and look at the data here. All right, our initial mass, 62.57 plus 5.004, we have 67.574 grams, and that is the mass before the reaction starts. And then after the reaction is complete, our mass is 65.87. Excuse me, this number up here is, wrote that number down wrong. It was 67.574. So the difference in those two numbers, 67.574 and 65.87, is going to give us the mass that was lost in this reaction. So the mass that was lost was 1.704 grams. Well, we know if that was lost, that was H2O and CO2. So now we can simply use the fact that when baking soda decomposes, 36.9% of the mass is lost. So 1.704 grams over X, because we want to find out how much baking soda was decomposed, times 100 is equal to 36.9%. Working that math out, 1.704 divided by 0.369, and X is equal to 4.62 grams. So now if we want to find the percentage that was baking soda in the original mixture, 4.62 grams divided by 5.004 times 100, and we get about 92.3%. Hope that was helpful. This was a challenging problem. Maybe the biggest challenge was the equation up here and remembering what happens when baking soda decomposes.